Okay, so good evening, everyone. I think I'm audible and visible to all of you. So if I'm audible and visible, so please ping me yes or no, so that we can start with the class. Yeah. Okay. So everyone is yes. It simply means I'm audible and visible. So let me share my screen and quickly we can start with the class. So basically, guys, in my previous class, I was talking about some of the basic statistical concept, and I believe we talked about a mean, median, mode, standard deviation, population sample, and again, so we talked about a normal distribution and something around that, right? Now, so continuation with the same lecture. So let's try to understand couple of more things with respect to statistics, which you are going to use it in almost all the algorithm and even in your like day-to-day life basically, and which will help you out in terms of understanding like a core concept inside the statistics. So here in stats lecture, so today we'll try to understand something called as hypothesis testing. We will try to understand what is a meaning of p-value, by the way. We will try to understand basically what is a t-test, or we can say student t-distribution. So it's another name for this one. So t-test, basically. We can try to understand even a Z test. So what is the meaning of Z test when we are going to do a t-test, when we are going to do a Z test? We are going to understand something called as chi-square test. So chi-square test. Now these concepts are very very important in terms of like using this statistics in your machine learning algorithm, deep learning algorithm, or even in terms of evaluating a data or evaluating a accuracy of the model. So this is going to build a base for all of you. So one by one, step by step, we will try to understand each and everything. So any idea, anyone, that what is the meaning of this hypothesis testing? A very first point that I have written over there. Yeah. So what is the meaning of this hypothesis testing? Any idea? Any one of you? So Soeb is saying assumption. Okay, fine. So what about others? So do you have any idea what is the meaning of hypothesis testing? Okay, Jitendra is also saying assumption. Okay, fine. Uh, okay. Any other answer? Okay. So basically, see, when we are trying to talk about something called as hypothesis testing, hypothesis testing. So first of all, what is a meaning of this hypothesis testing definition wise? So generally, we try to take or we try to make a lot of decision even in our day-to-day life. For example, so if I will be able to get this much of marks, I will be able to get an admission into this particular college. We try to say that the average salary of any data scientist is maybe 10 LPA. Junior data scientist is 10 LPA. So again, we try to make a assumption over there, right? So it can be lesser than 10 or maybe it will be more than 10. Depends upon the data that we are going to collect. So of all the data scientists in a particular region or maybe a state or maybe a country or maybe into a continent, right? So again, when we say that average salary is 10 lakh, we are not sure about it basically, right? So we are just trying to assume it that okay, so salary is going to be 10 lakh, but it will be less than, it will be around 10, or maybe it will be greater than 10 lakh. So again, so in a like a court proceeding, so we try to say that okay, so you are guilty, and then a position will try to prove or will try to disapprove or fail to prove it. So in that case, we can say that particular person is guilty or that particular person is not guilty. So everywhere you will be able to see that based on the evidence, we try to take a decision, right? We try to take a decision. So we try to take an assumption, we try to take a hypothesis saying that this could happen, right? And then we try to disapprove it, or we try to find out all the possible data or all the possible points, so which is going to disapprove my assumption. And if I will be able to disapprove my assumption, so in that case my alternate is going to be true, otherwise the assumptions that I have taken, it is going to be true. So this is something which happens in a world of hypothesis testing. Same thing is going to happen in a world of hypothesis testing. For example, so maybe there is a company so who tried to package a chips, right? So we all eat chips and all those, like a packaged item. So they are claiming that every packet is having 50 gram of chips. Let's assume, right? So every packet will be having 50 gram of chips. But there is a claim, right? So there are some influencer who is making a claim that no, that company is wrong. They are saying that there will be a 50 gram of chips, but they are not providing 50 gram of chips. Maybe in a packet there are 45 gram of chips, right? Or maybe like a lesser than 50 gram of chips which is available inside that particular packet. So in that case, company will say that okay, prove it, prove that particular claim. So maybe that influencer has to go and they have to collect a random chips packet, maybe from a different shops, or maybe go down, or maybe from a warehouses, right? So they have to collect a chips packet, and then maybe they have to take an average of it, and maybe they have to do some sort of a calculation. And if person is able to prove after doing that calculation, after collecting a chips packet, technically that is a data, right? That is a data for that particular case. So if they are able to prove that the company is not providing 50 gram of chips in every packet, in that case influencer is right, right? The claim which was made was right. Otherwise, if that like influencer is failed to like prove that, in that case company is going to be right. So this is what happens in a world of like a statistics, you can say, or even in a general day-to-day life. So we try to assume something, and if we are failed to prove the assumptions, in that case assumptions is true. If we are able to prove it, my points, basically our points, if I'm able to prove it, so in that case my assumptions is going to be right. And this is where this entire hypothesis testing comes into a picture. So with the help of data set, so we try to choose a different kind of a test under this hypothesis, and then we try to prove it, or we try to disapprove it, or we fail to prove it, I would say. Rather, I would say that we fail to prove it. In that case, hypothesis which was made initially is going to be true. So around this hypothesis world is going to move, and there are so many different kind of a testing you will be able to see over here. So when we say like a t-test, or maybe a jet test, maybe a chi-square test, all of these tests, it's getting derived from a hypothesis testing itself, which is a very important concept in a statistical world, by the way. So now when you are going to talk about a hypothesis, so you will come across a couple of terms, by the way. So let's try to talk about that particular terms, so that we will be able to use those terms while doing a calculation in my today's class as well. So here the very first term, and I believe we all are aware about it, is called as population. So POPULATION, populations, let's suppose. Yeah. So population means what? Population simply means that for the particular use case, if I'm able to collect all the data, right? In that situation, I will say that I have a population data, right? That is the meaning of a population for a particular use case, whatever problem that I'm trying to solve, or for whatever I'm trying to build this hypothesis, or I'm trying to perform some sort of a statistical operation. So in that case, that is called as population. Okay, fine. Now there is a term called as sample. I believe we are aware about it, right? Sample. So I have given you a chips example, right? So company is manufacturing maybe a lakhs and lakhs of packet on a daily basis. Now you can't run that kind of a test to prove or disapprove, right, on all those lakhs and lakhs of packet. So what I will do practically, so I'll go and I'll try to collect maybe 10 packet, 20 packet, 50 packets, and I'll try to run my calculation on those samples, right? Because population is not possible for me, or it is not possible for me to collect all the data. So I'll try to work with the subset, or maybe like a subset of that particular data. And in that case, that subset is basically called as sample for that particular use case. Is it clear to all of us? Yeah, is it clear? I believe we talked about this population and a sample. As simple as that in terms of our data. Now, there is something called as, in a world of hypothesis establishment, so you will be able to see there is something called as null hypothesis, and we try to denote it by using H0 or HO, you can say, right? So there is something called as null hypothesis, and it's nothing but a default assumptions that we are going to make, right? So whatever assumptions we have made, that is simply called as null hypothesis, whatever, for whatever case. So for example, if I'm saying that chips in a chips packet basically, so yes, so basically the weight of all the chips packet is 50 gram, right? It can be lesser, it can be more, but yeah, so I'm saying that okay, so chips packet weight is going to be 50 gram. That is my default assumptions that I have assumed basically. So this is technically called as default assumptions, whatever default assumptions we are going to take with respect to a particular case that I'm trying to solve. Now there is something called as, just opposite to this, right? There is something called as alternate hypothesis, and we can denote it by using H1. So it's nothing but just opposite of a like assumptions, right? So whatever we want to prove, so let's suppose if I'm trying to prove that no, chips packet weight is not 50 gram, it's a 45 gram, or maybe it's not 50 gram, maybe lesser than 50 gram or more than 50 gram, right? So that is something that I'm trying to prove, and that will become my alternate hypothesis for a particular case. If I'm trying to say that by default assumption is going to be that salary of junior data scientist is going to be 10 lakh. It can be less than that, it can be more than that, right? But 10 lakh is going to my default assumptions, and then lesser than or greater than is going to be my alternate hypothesis, or you can say the things that I would like to prove. So whatever I wanted to prove, so what we want to prove, right? So this is going to be my alternate hypothesis. I'll try to call it as a alternate hypothesis, case by case basis. So in every cases, your assumptions is going to be different and your alternate is going to be different, whatever you would like to prove, maybe for a court case, for any criminal charges, or maybe any kind of a charges basically, right? Or maybe like the weight example which I was trying to give you with respect to a chips packet, or maybe like a average salary. So this is going to be the alternate, whatever we want to prove, that is going to be the alternate. Now there is something called as significance label. Significance label, and we try to denote it with alpha basically. So alpha. Now what is this basically? This is the new term for all of us, right? So here significance or significance label or alpha is nothing but the risk, right? The risk we are willing to take for being wrong basically. So whenever we are trying to prove or disapprove something, so obviously there will be a error margin, right? So error margin, maybe we are saying that there is a 0.5% chance, maybe there is a 5% chance, so maybe by 5% is a error margin. And if something is falling under 5% of error margin, it simply means that my null hypothesis is true, right? 5% error margin is acceptable basically. So if someone is claiming that if company has already made a claim that the chips packet weight is basically 50 gram, and if you are able to find out that weight is somewhere between 49 or maybe a 51 gram, again it's not a fault from a company side, right? It's not a fault from a company side basically. So whatever claim that company was trying to make, so again that claim is correct. In case of a salary of a data scientist, so let's suppose there is a claim that average salary of a junior data scientist is 10 LPA, right? If you are able to get somewhere between 9.5 to 11 somewhat, right? So again we have a delta, we have an error margin over there, and if something is falling between that error margin, we can say that whatever I have assumed, whatever was my assumption that data scientist salary is going to be 10 LPA, it was correct, right? So I was not trying to make some sort of a false claim over there, because in every process there will be some sort of a error, right? It's not like if someone said 10 LPA, you will be able to get 10 LPA, or everyone will be able to get 10 LPA. Someone will get 9.8, someone will get 10.2. It depends, right? Depends. So this is something called as error margin, right? The risk, I would say. So risk, we are willing to take of being wrong, right? So this is the definition we can try to write. Then there is another term you will be able to find out, a test statistics. So you are trying to prove or you are trying to disapprove something, right? You are trying to prove or you are trying to disapprove something. Now to prove or to disapprove something, so obviously you are going to do some sort of a test, right? So unless and until you are not able to do a test, how you will be able to prove it? And there are a different kind of a test which has been designed, which has already been designed, which is already available in our statistical chapters, right? Which is going to help you out to prove something or to disapprove something, right? So you either you will be able to reject a null hypothesis or maybe you will end up accepting a null hypothesis. So test statistics, or I can say test stats basically. So we try to do a different kind of a test. So we try to do a jet test. We try to do a t-test. We try to do a chi-square test. This is the symbol of chi. So we try to do a chi-square test. All of these kind of a different kind of a test, which has been already defined inside the statistics procedure wise, that okay, so in this situation you should opt for this test or that test. Everything has been like a design inside the statistical concept. Then there is something called as p-value, probability, you can say probability value, right? So what is this p-value, by the way, in case of a statistics? So p-value is nothing but a probability that our sample, right? So whenever we are trying to do a test, basically, so we'll try to find out the probability. So what is the probability that my null is going to be correct or my null is going to be incorrect? Null hypothesis I'm trying to refer over here. So here, basically this p-value is going to tell you that probability that our sample result happened to be a random choice. Random choice means a wrong choice, basically. So this is something it is going to tell you. So P always going to talk about a probability value that you will be able to derive from your statistical test. Maybe t-test, maybe jet test, maybe chi-square test, maybe ANOVA test, and other different kind of a phi test. So there is also called as there is another test called as phi test. So from all of these different kind of a test, you will be able to derive this p-values. So these are the common term that we will be dealing with in my today's class, right? These are the things that you all are going to basically like encounter, and one by one, with the help of mathematical example, with the help of derivation, with the help of calculation. So we will try to understand each and everything in a step by step manner. Yeah. So is it making sense to all of us, guys? Yeah. Yes. Okay. Now let's move ahead, right? Let's move ahead over here. So here the core logic is, let's try to take one example. So let's suppose we are trying to take an example of a quote over here. So we are basically right. So let's suppose I'll try to give you a lot of like examples over here, a lot of different kind of example from a different segment, so that all of you will be able to understand things in a better manner. So here, if I'm trying to say that H0, H naught, so it's nothing but it's called as null hypothesis, right? Okay. So here, let's suppose my null hypothesis says that in terms of a court or in terms of a criminal proceeding, that the accused is innocent, right? So what is going to be my H1 or alternate hypothesis? So my alternate hypothesis is going to be opposite to this one. So if null is saying that accused is innocent, so in that case, I can say the accused is guilty. So either this is going to be true or this is going to be true. In any circumstances, in any situation, both of this is not going to be true. So either my H0 is going to be true or my H1 is going to be true. So either of this, right? Either my null is going to be true or maybe my alternate is going to be true. And obviously, evidence wise, so I have to propose or I have to bring some sort of a record. I have to bring some sort of a data, right? So if I'm able to bring a data which proves that right, which proves that that accused is guilty, then null hypothesis is going to fail. If I'm not able to bring a data, right? So let's suppose I'm the lawyer, so who is trying to prove this one, the accused is guilty. And if I'm not able to bring all the evidence or all the data, so which is going to prove that that accused is guilty. So automatically, even though accused is going to be guilty, but still accused is going to be innocent if I'm not able to provide a data, right? If I'm not going to provide the data. So this is one of the case, I would say, right? This is one of the case that you will be able to find out in this particular situation. So here, every time whenever you will try to solve such kind of a problem, whenever you will encounter this kind of a situation, so you have to build h naught and h1. Means you have to establish basically your null hypothesis, and then you have to establish your alternate hypothesis, means assumption basically, right? So you are supposed to build your assumptions and then the alternate one you have to build it. That's a step number one. Now once, so that's going to be a step number one, let's suppose. Now what is step number two, right, in like this hypothesis world basically? So step number two is going to be, you have to choose a significance label. So significance label means I have already written over here a risk, right? So significance level, which is alpha. So how much wrong so you can be, you can basically afford, right? So even if you are going wrong, even if there is a margin, right, plus minus delta is there, so how much delta you are willing to cover, or how much risk you are willing to cover. So again, so whenever you try to do a investment into a stock market, so we always try to do this kind of assumptions, even in stock market on a day-to-day basis, that there is a 5% chance that this stock will go down, right? And only with that confidence, because whenever you try to do some sort of an investment, even in a stock market or any other kind of an investment, right, so you try to do assumptions internally, right? Maybe you talk to your friends and then your friends say that, or maybe like influencers or like social media or maybe news is saying that this stock will go up. Now, no one can give a guarantee, by the way, right? No one can give a guarantee. So we all are aware about that kind of a situation. So it depends upon so many different kind of a factors, right? So internal company factor as well as from a, depends upon the market as well. And lots of variable coming from a market, news, promoters, and like a, state of the company and many more things. So no one can say with the surety that this stock will go up all the time, right? So we try to build a hypothesis. We try to build a null hypothesis in my favor that, okay, this stock will go up, right? And when we say this, so we say that, okay, there is a 5% chance, or maybe there is a 10% chance, means risk, I'm trying to say, right? Risk over here. So there is a 10% risk, there is a 5% risk. Even when broker will come to you, right? Any stock broker will come to you, they will say the same thing. Okay, fine. So I'm trying to maintain and manage a portfolio of XYG people. And there is a 5% chance, there is a 1% chance, there is a 2% chance that your portfolio will go down, or maybe your portfolio will go up. So basically everyone trying to make a claim in this entire world. This is how this entire universe actually works, right? And everyone is trying to make the world, and they always try to add these words, that there is a 10% chance, there is a 5% chance that this will go down. This will go on a negative side. And every time we try to assume that, we always try to take that kind of a risk. So when someone is claiming, or when someone is saying that, okay, fine, so there is only this much of risk. So when we see a lesser risk, we say, okay, fine, so invest my money as well, right? So even like maintain and manage my portfolio as well, right? If risk is very high, if risk is 50%, I'll simply say no, right? I'll simply say no if risk is very high. So whenever we are trying to do some sort of a hypothesis, whenever we are trying to build, so we always try to choose automatically, right, that how much risk we are willing to take, right? Not more than that, not less than that. This much is the risk which I'm going to take: 1%, 2%, 5%, 10%, whatever. So this is something called as, so we used to choose. So whenever we are trying to prove or disapprove, so we try to choose significance label. It's called as alpha. I think I have already written over there, right? So significance label is called as alpha, basically, and notation wise. So maybe like a most common significance label that we try to consider is a 5%. So you can say that alpha value in general that we try to consider is a 0.05, 5% basically, right? In terms of percentage. So 5%. The first part is establish the hypothesis. Second step is choose the risk that you are willing to take, right? Now the third part. Yeah, third part. So you have to disapprove or prove, right? This hypothesis. So in that case, what kind of a test you will be opting for, right? What kind of a test you will be performing? Again, test wise, there are a variety of tests: jet test, t test, chi-square test, ANOVA test. So there are so many different kind of a test which is available in the market or in a statistics. You will be able to find out. So here, so choose a right test. This is also important. Choose right test. Now, so I can try to choose Z test. There is a test name called as Z test. We'll be talking about that with respect to example. So when you are supposed to choose a Z test, so when you have a large sample or maybe known population standard deviation, SD, standard deviation. I believe we all know what is the meaning of standard deviation. Then one, then two, then three. So we are already aware about that. So when we have a very, very large sample, right, maybe more than 100, that is going to be a pretty much decent sample, I would say, in a statistics world. So in that situation, I will be opting for a jet test. Yeah. Or whenever we are aware about a standard deviation of a population. So in that situation, we'll be opting for a jet test. There is another kind of a test called as t-test. Now, when we are going to do a t-test, by the way, so when we have a small sample, in general, we say less than 30, but again, that depends upon the intuition, right? And unknown standard deviation, right? Just opposite to jet test. So jet test, you are supposed to perform with the large data set, by the way, as simple as that. And t test whenever you have a small data. So in that case, you have to go ahead with the t test. Yeah. Now there is another kind of a test you will be able to find out, which is called as chi chi-square test. It's represented as this way. So this is the symbol for chi. So when you are supposed to do this kind of a test, so whenever you have a categorical data, not a numerical one, categorical data comparison or group wise comparison, whenever you have to do, so you can go ahead with the chi-square test. And then there is something called as ANOVA, acceptance of variance test, we say. So whenever we have more than two category comparison, or you can say two, more than two. That's the reason I have written greater than, right? So group comparison. So these are the different kind of a test and depends upon the nature of a data. So we try to select a different kind of a test. So yeah, basically we are able to build the hypothesis. We are able to take a risk over there, and then we are going to select which test I'm supposed to do on what kind of a data, right? So I think till this point, it's clear. Yes, everyone. Yeah, clear the flow. Yeah. Now, so here in a fourth number step, right? So in a fourth number step, and again, this is a general procedure which I'm going to define, and this is a procedure you are going to follow for doing any kind of a test and to prove or to disapprove anything in the statistical world. And this is going to give you a very, very clear idea that, okay, so what is next that I have to do basically. So once you will be able to choose a particular test, so you have to do a compute test stats basically. So whether you are going to choose maybe a Z, you are going to choose T, maybe chi-square, or maybe acceptance of variance, ANOVA. Yeah. So you have to do a computation of those results, right? You have to do that comparison, computation. And then a fifth part. right? So you have to basically compute a value, p value. I have already mentioned over there, right, in above. So p value. So p value is nothing but it is going to talk about the probability of occurrence of this particular event. It is going to capture in that particular manner. So you have to basically compute a p value, right? You have to basically compute a p value, and then in a step number 6, what you have to do? So you have to compare what? So you have to basically compare a p value that you will be able to get with your alpha. So significance label, or you can say the risk that you were willing to take. Yeah. So if your p value, right? If your p value is lesser than alpha, means lesser than risk, basically, if the probability that you are able to get is lesser than risk, so in that situation, we try to reject a null hypothesis. If your probability value is greater than equal to alpha, so in that situation, we fail to reject null hypothesis. Simply means that, so whatever assumption that I have taken, so that is going to be true. So my p, the probability which I'm trying to calculate, right? So the computation which I will do with respect to the data set and all those tests that I will try to run. So if my probability value is greater than risk, right? In that situation, so we will be not able to reject a null hypothesis. It simply means that whatever assumptions that I have taken, that assumptions is actually a correct assumption, right? That I will be like assuming. So, and then we can try to like, in a step number 7, we can try to give a conclusion that whether we are going to select or we are going to reject a null hypothesis. If we are able to select it, simply means that alternate is wrong. And if we are able to reject it, so in that case, H0 is correct, basically. So this is the 6th step that we are going to follow each and every places. Yeah. So is it making sense, guys? It will make more sense. So when I'm going to run through one of the example, and when I'm going to do all of these calculation one by one, one by one, one by one. Yeah. Okay. Now, these are the steps, and again, you don't have to remember all of this step. Maybe for like a next 15-20 minute, you can go through it and maybe you can try to remember it. But once we are going to do a math, once we are going to do a calculation, you will be pretty much sure about it. Yeah, you will be pretty much sure about it. So let's try to do a math. Let's try to do a calculation with respect to one of the example. Yeah, one of the example. Shall we go ahead, guys? Yeah. Yes. Okay. So Jitendra is saying, please give an example of a real time. I mean, like all the examples are real time only, right? Okay, so let's take one example. Yeah, let's take one example, and then let's try to understand all of these things with respect to the steps that we have written, so that you will be able to do any kind of a test on your own. And again, so same thing, you can write it down maybe in a Python programming in a Python. So you will be able to find out the inbuilt library where you have to pass the data, and everything will be done by library itself. So this is how easy it is in terms of Python or maybe R programming. But yeah, so here we are going to do each and everything in a step by step manner, by the way. Okay, fine. Now, so let's take one interesting example. So I would like to show you one very, very interesting example to give you a beautiful understanding. Okay. So let's suppose, example wise, so here, let's suppose I'm taking an exam, right? I'm taking an exam inside this class, and I'm going to make a claim that the average score my student uses to get is equal to 80%, 90%, or maybe 100%. So every school try to make this kind of a claim, right? Along with that, so every institute, so whenever UPSC result will be out, IIT JEE result will be out, maybe board result will be out, or NEET result will be out. So everyone try to claim that we have produced a lot of ranks under 100, maybe under 1,000, under 500. So all this institute and universities and schools used to make a claim. Even universities, right, or maybe a colleges, they try to make a claim that last year, on an average, everyone was able to get 6 LPA, 7 LPA, 8 LPA, right? Something like that they used to claim. So let's suppose I'm a teacher, right? I'm a teacher and I'm taking your exam. And again, same thing is like you can try to replicate the exactly same thing in everywhere, right? In every places, even with respect to the chips packet which I was talking about, by the way, right? That company is claiming that basically weight of a particular chips packet is 50 gram, but maybe this could be lesser than or more than that. So that will be the alternate one. So here teacher is trying to claim that on an average my students uses to score maybe 70 in a mathematics, right? So I teach normal mathematics, and yeah, so on an average my student used to obtain 70. Yes, 70. So this is a claim. So here I can simply write that a claim from teacher is that on an average my students get 70 out of 100, obviously, right, in mathematics. So this is basically a claim, right, that teacher has made, that on an average my student used to get 70 in a math exam, right? So this is how I used to teach a mathematics. Then there is a person, so who is not who is not agreed with this teacher. They say that no, so maybe you are doing or you are trying to make a false claim, right? You are trying to make a false claim. So what that person will do, so that person will go into a class and maybe they will that person will be able to collect some of the information. Some of the information means a math score basically from some of the student it will try to obtain, so that it will be able to prove his claim, or maybe it will be able to disapprove. Disapprove means teacher is right. So here, that person is going to a class and he has or maybe she has collected a record, right? Records of student math score, right? So maybe, so he went to one student and he has obtained basically 65, and then other student, so 68, other student 75, again other student 80, and then there is another student who has obtained maybe 72. So this is the marks that that particular person is able to collect. Yeah. And teacher is claiming that my student on an average, they try to obtain 70% marks every time, right? Every time they used to obtain 70% marks. Now, so here, what is the null hypothesis? So first of all, I'll try to move through a steps, right? So step number one, establish the hypothesis. Step number two, choose a risk factor. Step number three, choose a test type. Step number four, compute a test. Then step number four, compute the test. Step number five, compute a p-value. Step number six, take a decision, a final decision, right? So this is the exact step we are going to follow. So here, if I have to build my null hypothesis, which I'm going to denote as H naught or H0. So my H0 says that on an average, I'm trying to denote this average by mu, right? So average marks is going to be 70. This is a claim, right? Teacher is claiming that average marks is going to be 70. Okay, that's fine, right? So basically, will be alternate hypothesis. So there will be H1, right? H1, which says that no, average marks is not equal to 70. This is the alternate one, and this is my step number one. So I'm able to build a hypothesis. Either teacher is going to be right, or maybe the person who is trying to make a claim is going to be right. So here when I say mu is not going to be, or average is not going to be 70, it simply means that it could be greater than 70 or it could be lesser than 70, both side, right? Both side it is possible. If I have to do a test, so where marks should be lesser than 70, then there will be a different situation. But here situation says that okay, basically we have like a maybe greater than 70, the student is going to get maybe more than 70 but not 70. This is what it means. So we are able to build our hypothesis. Now step number 2. So hypothesis is built as per the statement which was given, right? Step number 2. What is step number 2? So choose a significance label. So okay, fine. So significance label is going to be 5% error margin I'm going to keep. So my alpha is going to be 0.05. 5% error margin I'm going to consider, right? So 5% plus minus is going to be fine. Otherwise, it's not going to be fine for me. Now, third one, step number 3. What step number 3 says? So step number 3 says that you have to choose a right test. So which test I'm supposed to choose, guys? Yeah. So jet test, t test, chi-square, or ANOVA. Afifa is saying jet test. Why? Rakesh is saying T test. Anuj is saying T test. Soeb is saying jet test. Chitananjan is saying, okay, so I think people are in a favor of a T test. Now read out the statement that I have written with respect to Z and T and Chi and ANOVA. So basically, we are not doing a categorical data. We are not dealing with the categorical data. So chi-square, no. We are not doing comparison between two groups, more than two groups. So again, ANOVA, no, right? So chi will be no, ANOVA will be no. Remaining is Z and T, right? Now, Z test. So when Z test will be applicable? So Z test will be applicable when we have a large sample. Large means maybe more than 30 or 100, some kind of a samples. Do we have that large sample? We have a very, very small sample, right? A small sample which is lesser than 30. And we are not even either this or maybe we are aware about a standard deviation of the population. Again, a standard deviation is unknown for the population, right? I'm not aware about, basically I have not collected the entire university data or entire class data. So I was only able to collect a data of 5 students. Yeah. So in that situation, a clear winner for this particular use case is who? A T test. Can I say that? A clear winner is basically a T test. Can I say that? Those who are saying jet test or something else. Yeah. So I can simply say that I will be going ahead with the T test. Okay. So now we are able to move till step number 3. Step number 1 done. Step number 2 done. Now we are able to choose a test. And believe me, majority of people so who have learned statistics for a data science, right? Again, that's fun. But yeah, majority of people who have learned data science, statistics for data science, right? If you'll go and ask them, they will be confused between Z, T, Chi, ANOVA, Phi, Phi test, and all those things. I mean, like, there will be a set of people you will be able to find out who can do a calculation, but they don't know why they are doing it, right? Or maybe not able to relate with the real world. That's the reason so I have given you a clear step over there. So that always go with the flow, go with the step by step, and believe me, this is never going to fail, right? And you will be able to reach out to a final conclusion without any kind of a confusion. Okay, fine, that's cool. So we are able to select our test. So we are going ahead with what? We are going ahead with the T test. Okay, that's cool. Now step number 4 says that if you are able to select your test, then do the computation, means calculation step, by the way. Yeah. So do the calculation, means computation of the T test. So I have to calculate this T. Yes, I have to calculate this particular T. Now, how I will be able to calculate this particular T? Any idea? Anyone? Yes. Yes, any idea? So how I will be able to do a calculation for T? So here in a step number 3, I will say that I will be doing T test. Okay, cool. We are able to select a test as sample is lesser than 30. That's my like a a counter for that, right? That why I'm choosing T test. Okay, That's cool. Now, step number four, compute t. So how I will be able to do a computation for a t? What is a formula for a t? So formula of a t says that sample mean, right? So generally we try to denote a population mean by mu, and let's suppose if there is a sample, so we try to denote sample mean by x bar, right? X bar. So sample mean minus population mean divided by standard deviation by root of n. N is nothing but number of sample. S is nothing but standard deviation of a sample. Yeah. So we have to calculate basically a mu. So what is the value of mu, by the way? What is the mean, like a value of a population mean? Can I say population mean is nothing but the claim? Yeah. So teacher is saying that all of my students used to like get, 70. This is what teacher has claimed, right? For all, everyone. So can I say that I'm aware about a population mean? Yes, everyone. Yeah. So Afifa is the only one who is giving answer. What about others? What happened to others? Are you sleeping or maybe are you like occupied with something else? Okay, my Arian is saying yes. So keep on saying yes or no so that so basically when you will interact, right? So then only you will be able to understand. And believe me, if you are able to understand these things only once in a lifetime, you will be able to explain these things to anyone in this entire world, to a interviewer. Plus, you will be able to use it even in all of your algorithm. Yeah, not just in machine learning, in deep learning, in NLP, in terms of LLM evaluation, everywhere, because these are the fundamental concept, right? And again and again and again, you will encounter this concept, same kind of a concept. I'm not saying that something different, exactly similar kind of a things you will be able to encounter again and again and again. So it's a once in a lifetime kind of a learning, basically, and it's not tough. It's very logical, very relatable. You will be able to find out. So here, formula of t says that mean of average of a sample x bar, which I am trying to represent. Let me write it down so that when you will look into this slide in a future, you will be able to understand. So sample mean, mu is nothing but population mean, right? S is nothing but sample standard deviation that we are going to calculate. N is nothing but sample data or sample number of data, you can say number of like a samples, in other word, number of data. Fine. So we are aware about a total number of data that we have. We are not aware about a sample standard deviation. We have to calculate it and we know how to do a math, how to do a calculation. We are aware about this population mean, which is eventually 70. So teacher has said that all of my students used to get 70. So basically she or he was talking about everyone, the entire population. And sample means obviously I can do a math. I have a data, right? I have like a sample data with me 65, 68, 75, 80, and 72. So these things are available to me. So this is going to give me a calculation for my T. So eventually I will be able to complete my point number 4. So let's try to complete a point number 4. Then we will jump into point number 5. Yeah. So first of all, let's do the computation. So here, anyone who can like, give me a value of X bar. So just use this data, guys. 65, 68, 75, 80, and 72. Give me the calculation quickly. Open up your calculator, do the math. Soeb is saying 72. Is it correct, everyone? So anyone who can cross verify the claim that Soeb has made. Okay, so now everyone is saying Sam, Afifa, Tyler, everyone is saying 72. Okay, that's cool. Then I'm going to write it down over here, 72. This is my sample mean, average, sample average, right? Whatever sample that I have taken. Okay, so now just try to give me, I'm aware about this mu, which is a population mean. So it's going to be 70. Now try to give me this one, standard deviation. And this is the standard deviation of a sample, not a population. And there is a difference between a standard deviation of a population and standard deviation of a sample. Anyone who is aware about it? Yeah? Anyone who is aware about it? No? Okay, so uh, no one? N minus 1 for sample, exactly, because of error. So basically, whenever you are trying to do the calculation for this sample standard deviation, so it is going to be root of summation of data, so xi minus sample mean, which is x bar, not mu, divided by n minus 1, not n. So that you are supposed to actually use. Now give me standard deviation, sample standard deviation, guys. Now tell me what is going to be a sample standard deviation. Yeah, so G1 is saying 5.25. I think G1, you have not taken n minus 1. So in a denominator, there will be n minus 1. Yes. Yeah, Sam is saying 5.87. 5.87 is actually correct. Just use this formula. Data minus mu or data minus x bar. X bar is nothing but a sample, like a mean sample average and a square, summation of a square and then divided by n minus 1. So basically you will be able to find out 5.87. If you are going to calculate based on n, then there will be a different result. So that's the reason this one. So here 5.87. This is fine. Now what is my n? N is nothing but 5. Yeah, n is 5. Okay, so if we are able to reach till this point, now tell me t. We have a formula and we have all the values over here, right? So now tell me what is t. So we have like a x bar, we have mu, we have basically s and we have n. We have everything which is required to do a math for a t. So now tell me what is t. Yes, what is t? Just put everything in a formula and you will be able to get a value of t. Okay, so Sam is saying 0.76. I believe Sam is. What about others, guys? I'm waiting. So I'm just waiting for your answer, everyone. Yeah, so I think only Sam has done the calculation. What about others? Why you are not doing calculation? You have formula, you have all the values, and I believe you have a calculator in your mobile phone as well as in your system. Okay, so Afifa is saying basically 0.763. Yeah, 76 basically. So Sam and Afifa, Soeb is saying 0.761. Praveen is saying was 0.76. So let's take, as all of you are saying 0.76. So I will be considering 0.76, right? That's like a fair one. Okay. So 0.76 is a T that we are able to get. So my fourth step is complete. Compute a value of t, and with the help of this formula I'm able to do a computation for a t. Now what is my next step, by the way? So compute a p value. So t we are able to compute. Yeah, so till fourth point we are able to do a math, we are able to do a calculation. Now so I have to compute a p value. Any idea how we are going to calculate a p value, by the way? Any idea, any thought? Because that is a next step, and then only I will be able to do a comparison. Any idea how we can calculate a p value, a probability value, by the way? No idea. Okay, that's fine. No idea. I'm like I was expecting that, so it's completely okay if you don't have any idea. In the next 5 minutes, you will be having enough idea about that. So compute a p-value. So basically, if you will go to internet, we have like a till 4, right? So now I'll write a point number 5 over there. Compute p value. Okay. How we are going to compute a p-value? So what was a total number of data that we have? Total number of data is equals to 5. There is something called as degree of freedom, DF. Yeah, degree of freedom. So degree of freedom is always equal to a number of data minus 1. So eventually 5 minus 1 is equals to 4. Why I'm trying to introduce this new term degree of freedom, I'll be talking about that. So there is something called as degree of freedom, right? And degree of freedom basically says that it's a total data minus 1, so which is going to be 4 for me. 5 minus 1 is equals to 4 for me. Now, if you will go to internet, right? If you'll go to internet, so just like a log table, I don't know whether you guys have used a log table or not, because maybe in your time, so calculator was allowed, right? But if you are very, very old, I mean, like not that old, if you are 90 born kid, so at that point of a time, so we used to, like take a log table in our examination hall. So wherever we have to like do a calculation with respect to a logarithmic, so we try to look into the log table. In a later stage, all the schools, colleges, and universities, they have started allowing a calculator. A scientific calculator was allowed, by the way, right? But maybe for those 90s kids, before 90 or maybe around 1991, I believe, not beyond that, right? So used in 11th and 12th. Okay, a log table or calculator, scientific calculator, which one? I mean, like we all have used log, but yeah, in which mode? Log table you use, log chart you used to like take, or you used to like take a scientific calculator. Okay, log table. Yeah. So like I said, so those who are a little bit old said at that point of a time, those calculators was not allowed, or those calculator was not even that advanced. So we used to take a log tables so that we can do a calculation whenever those log based like things used to come. So we used to like bring a log chart with we used to take a log chart with us. That's a story, right? That's a old story. uh, so in a similar manner, you will be able to find out a t table. Yeah, so people have prepared a t table, and we can go there, and we can try to look into a t table basically. So how this t table looks like, so let me show you that part. So this is how this t table looks like, and you will be able to find out a t table everywhere over a internet. Yeah. Yeah, everywhere. And even you will be able to find out a website basically. So where you can just try to put all those values, and it is going to give you a T, right? It is going to give you a value from a T table. So you don't have to even look into this table, right? So there are so many websites which is available. Again, you can write a simple Pythonic function, which is going to give you that value. So in either way, that's completely fine. But I would like to show you some old approach, right? A raw approach, you can say, to do this calculation, so that you will be able to understand in the future that how this value is actually coming. Okay, so here this is a t table. I have already pinged you a link inside your chat. So you will be able to find out on this side. Let me increase its size, and let me write down something. So here you will be able to find out something called as degree of freedom. Just follow my pen. Yeah. So here we have DF, and you can try to open up this T table inside your system if you want. So here you will be able to find out something called as degree of freedom. So degree of freedom 1, 2, 3, 4, 5, 6, and so on, right? On so on. Now, this is on this axis, you will be able to find out. Now, on this axis, you will be able to find out basically something called as one tail and something called as two tail, right? So, what is the meaning of one tail? What is the meaning of two tail? So, whenever we are trying to do a comparison greater than or lesser than, so in that case, one side comparison, only one side, right? So, in that case, it's called as one tail test basically. Whenever we are trying to do a comparison both the side, for example, in our case, teacher has claimed that average marks is going to be 70. Yeah, that's a claim from a teacher. and marks can be greater than 70 as per my alternate hypothesis. So marks is not equal to 70. It simply means that it could be greater than or it could be lesser than, right? It could be greater than, it could be lesser than, right? Okay, so I will try to go ahead with two tail, right? It could be greater than, it could be lesser than, as per my alternate hypothesis, which I'm trying to prove or disapprove, let's suppose. Now here so in the similar situation, right? In the similar situation, so what is my risk label? So let's suppose I'm considering this two tail. So my risk label is basically 5%, right? So I'll try to look into this 5%. And here, so I'll look into my degree of freedom. So what is my degree of freedom? Data minus 1. So basically my 4. Degree of freedom is 4. So I'll try to intersect this and this. Basically, this is my alpha, a risk. So basically, this is how this table has been calculated. I'll try to even talk about more as we'll progress inside the class. So how, and this is pretty much related to my previous class, the previous class where I was talking about a standard normal distribution. Where, so what is the meaning of a standard normal distribution, by the way? Anyone? I think I talked about that in my previous class. I remember. Yeah. What is the meaning of that standard normal distribution? Mu is equal to 0 and standard deviation is equal to 1. That is the meaning of standard normal distribution. And I have given you a formula basically to sift it. So any normal distribution, you can try to sift it. So you just have to sift the scale and then eventually your data will be converted into a standard normal distribution. And that standard normal distribution, a bell curve, right? So it's actually a bell curve representation. And basically it is actually talking about, so let's suppose probability of this entire area is equals to 1, right? So basically this entire table, Z table, T table, all these things are being calculated based on that only, right? So it's pretty much logical and pretty much mathematical. So here, let's focus on our problem. So my degree of freedom is equal to 4. This is the meaning of degree of freedom, total data minus 1, right? And here, so our significance label, our alpha is equals to 0.05. So what is the value that we are able to get? We are able to get 2.776. This is the value that we are able to get over here. Yeah, 2.776 over here. Okay. So now I'm able to, after looking into my T table, or maybe you can open up some like online calculator as well. You can try to like put all the values which is required for online calculation. You will be able to get the same values. So my value is 2.776. So I'm able to calculate, this is my P value, probability value actually. Yeah, this is my P value, you can say, or T table value. Yeah, this is my T table value, you can say. So I'm able to get this T table value. So T table value says that, now let me go back with this number 2.776. So here, if I'll come, right? So here compute a p value. So here the t that I have computed, right? T that I have computed was, so with the help of like in a previous step, so that was 0.76, let's suppose 0.76. This was a t which I have already computed. And then from a table, right, from a table, so we are able to calculate something called as critical t value. We can say critical t value. Critical t value, right? For what? So for our significance label, means risk label. So for alpha 0.05. So if we are going to change our risk label, so obviously my values are going to be changed. And basically I have done that for two tail. Two tail means like lesser than equal to, but otherwise if in case of one tail, so again situation is going to change, numbers are going to change. A two tail because of my problem statement, right? So like it was not equal to 70 means it can be lesser than, it can be greater than, as per my problem statement. So two tailed, right? Two tailed, and which is approximately equal to, I can say, plus minus 2.776. This is something that I'm able to receive. Yeah, this is something which I'm able to receive, plus minus 2.77. Okay, that's cool, right? And what is the t value which I was able to calculate from the data? So the t value which I'm able to calculate from a data is 0.76, and the t value, we generally say critical t value, that we are able to compute from a table based on my risk label and tail is plus minus 2.776. We can try to say, right? We can try to say over here. Now, now, what is a next step over here? So how I will be able to, because in the next step I have to reach into the conclusion. Yeah. So till this point I'm able to do a math, I'm able to do all this like a calculation. So now it's time to reach into the calculation. In step number 6 I have to take a decision, so whether teacher is right or maybe uh, the person who was trying to basically the make a claim, so that is right. So any idea, guys? Anyone? Yes. So Saurav is saying fail to reject null hypothesis. How? Yeah. How? P is greater than alpha. Yeah. P is greater than alpha. Okay. Okay. Sati is saying P is greater than alpha, making sense because 2.776 is greater than alpha. Yes. Yeah. That's correct. So here, the t that we are able to get, so t is equals to 0.76, right? So t is very, very small, you can say. So our t, that the t that we are able to get, so our t is basically like a very, 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 very small. And what is our like a p value over here? Yes. Yeah. What is our p value? So p value is basically 2.776. So critical, okay, so Afifa is saying that is critical T is equals to P value. So I think everyone is saying 2.77 6. Now let's look into this table once again. I would like to show you something over here. So here, degree of freedom again. So if I'm like 100% accurate, or maybe if I'm trying to take 100 percentile over here, till this, right? So till this confidence interval, right? So you will be able to find out 3.219, starting from 0 till 3.219. This is the maximum value that you will be able to find out, even with respect to 1,000 degree of freedom. Means 1,000, even like 1,000 data you have. So even till that, you will be able to find out only this much. So 3.291. So anyone who is able to relate something from the previous class? Yeah. Anyone who is able to relate from a previous class? Yeah. Anyone? So three standard deviation. Exactly. Yeah. So you will be able to find out that this table is talking about like a like a length, or you can say a deviation, right? This table is entirely talking about a deviation. And again, so there is something called as critical value that we are able to calculate. Now let me show you something over here. So, what is the meaning of a critical value, and what actually it means with respect to this bell curve? So, let's suppose I'm going to draw a bell curve over here. Yeah, bell curve over here. Now, we all know that if I'm talking about a standard normal distribution, because everything is like a depends upon, or every table has been created based out of a standard normal distribution, and it simply means that average is equals to 0 and your standard deviation is going to be 1, right? Average is going to be 0, your standard deviation is going to be 1. So if I'm going to draw this line, so here mu is equals to 0, right? And then there will be one standard deviation, there will be two standard deviation, there will be three standard deviation on this side. Again, there will be one standard deviation, there will be uh, two standard deviation, right? And then there will be three standard deviation. We all know these things, like in a one standard deviation, there will be approximately 68% of the data, and then there will be like a subsequent percentage of the data I will be able to fit in. So basically that talks about the probability of occurrence or probability of happening something. Now, so here we have one SD. Till this point, we have two SD starting from this like origin, and till this point, three, you have a three SD, right? Three SD, two SD. Again on this side, so we have one standard deviation, then we have two standard deviation, and then we have three standard deviation, right? Okay. Now, so basically, we are able to get our critical value for this alpha 0.05. So what is our critical value? So our critical value is plus minus. We are doing a two-tail test, by the way, right? So 2.776 we are able to get. So 2.776 means, so there will be 2, and then in a red, I'm trying to draw this point. So 2.776 from my origin, from this point, right? On this side, 2.776. That's the reason I have written two plus minus. It's a two tail, means both side. We are going to check. And 2.776 will be like a somewhere over here. Let's suppose. So maybe I can draw a line over here. Right. So from this side, 2.776. Yeah, 2.776 on this particular side, I will be able to find out. So this is my critical C T value, I can say. And on this side, so this is my critical T value. Yeah, this is my critical T value. Now, so as we are doing a two-tail test, and our alpha is going to be 0.25, right? Our alpha is going to be 0.25. So basically, if anything is falling under this region, so sorry, my alpha is basically zero point 0.5, my bad. So my alpha is going to be 0.05, but as I'm doing two tail test, so it will be alpha by 2 on both hand side. So it's going to be 0.025. So basically 0.025 will fall somewhere over here, the red mark which I'm trying to do. And on this side again, so 0.025 will fall over here, somewhere over here. My value is basically, right? So my value is basically beyond this alpha, right? Or I can say that my value is 2.776, or it's not failing under this particular reason. Yeah, so it's not falling under that particular reason. So if it is not falling under that particular reason, if it is falling under that reason, so if it will be somewhere here, right, somewhere here or somewhere here, right, both on side, so in that case I can say that my critical T value is falling under this confidence, or I can say within this particular region. So in that case, I can reject a null hypothesis. But as it is not falling under that particular reason, right? As it is not falling under that particular reason, so I can simply say that I am going to accept a null hypothesis. It is not falling under a critical reason that I have, or rejection reason that I have. Is it making sense? Yeah, area under bell curve is going to be 1, and based on that this T table is been created based on that. And here, so you will be able to find out max to max, the max value is going to be 3.30 or 3.3, right? This is something that you will be able to find out, which is nothing but trying to tell me that, okay, fine, so on this side and this side, so max standard deviation that will go only as this much, and in terms of that you will be able to do the comparison, right? You will be able to do the comparison. So this is what this table talks about, by the way. Yeah. Now going back to our calculation. So here our calculation that we have done, it simply says that our t, right? So our t is basically 0.76. Yeah, our t is basically 0.76. So our t value is much smaller. Yeah, our t is much basically smaller, and the critical t value that we are able to calculate based on this alpha is 2.76. And compared to that, our t value that we are able to calculate from the data is very much smaller as compared to this critical t value. It simply means that the null means it is not falling under this critical. This is what it means. Now let's try to make a conclusion over here. Our t value is 0.76. The t value from here, from the t table that we are able to calculate is 2.76, which is very much smaller, right? Which is very small. It simply says, and it simply says that it is falling under a not rejection reason. It is falling under a reason. So our t value, so falling under a rejection, maybe our t is here, right? Our t is here, 0.76, right, on this side. And I'm allowed to go till this region. I'm allowed to go till critical region. I'm allowed to go till 2.76. And we are within that region. Yeah. If I'm going to cross this critical, means let's suppose my t is 2.9. So let's suppose if I have done the calculation and if my t is 2.9. So can I say that I will end up falling inside the critical region? Are you able to understand what we are trying to conclude over here? So let's suppose our t is 0.76. Let's take a different case. My t is 2.9. So can I say that my t is more than the critical? Means it will come somewhere here as per this graph, as per this bell curve. Yeah, it will come somewhere over here. Means it will come beyond a critical region. So my allowed region is, as per my table, as per the t table, my allowed region range is 2.776. If I'm going beyond that, right, if I'm going beyond that, it simply means that I will end up falling under critical region. It's still, that's the reason. So it's called as critical region, right? So I will end up falling under critical region. And if I'm falling under critical region, what does that mean? If I'm falling under a critical region, what does that mean? It simply means that reject the null hypothesis. Your alternate is correct. So now tell me, are we able to reject the null hypothesis or we are going to accept the null hypothesis? In this situation, the situation that we have in our hand, so are we able to reject it or are we able to accept it? We are going to accept it because my t is falling within the permissible range. I can go till 2.77. I'm just at 0.76. It simply means that the claim which teacher was trying to make, teacher was actually right. Yeah, with risk of 5%. Teacher was actually right. Now, as we have a very small data, look into this data. What teacher has claimed? On an average, this is what a teacher has made a claim, right? That on an average, my student used to get basically what? So on an average, my student used to get 70 marks. This is what teacher has claimed, right? Can I say that all of these numbers are fluctuating around 70? Agree or disagree, everyone? Agree. Now let's try to do a math once again. I will change a data. I will make a drastic change into a data. So I am like, suppose I'm that critic, right? I'm that critic. So whatever teacher has claimed, I'm not accepting it. So I went to the class, right? I have collected a data. So some student has received 5 marks, some student has received 10 marks, some student has received 4 marks, some student has received 2 marks, some student means 1, 2, 3, 4. And then let's suppose like some student has received 6 marks. Yeah. Now this is the new reality. This is a new marks. Fine. Point number 1 is done. Hypothesis is not going to change. Point number 2, critical range also I'm not going to change. I can make it 10%, 20%. I'm not going to do it. Let's keep it same, right? Now I will do the t-test as sample size is small. So fine. Point number 3 is also correct. Now come to the point number 4. Quickly do a math. Give me t. Quickly, guys. See, this is the data. 5, 10, 4, 2, 6. Do the math. Give me t value. Immediately, everyone. 5, 10, 4, 2, 6. Now calculate the t value. This is the t formula. So calculate, it's like a sample mean, then like, standard deviation, n we already have, it's 5, and then mu we already have. Now tell me what is the value of t. 5, 10, 4, 2, 6. Let me write it down over here. So 5, comma, 10, comma, 4, comma, 2, comma, 6. Yeah. And teacher's claim is same, 70 marks. Teacher has claimed that my like a student used to get 70 marks. Anyone who is doing a math? Anyone who is doing the calculation? 40. Yes, anyone? Okay, so he is saying minus 7.34. What about others? Yeah. What about others? Yeah. So Anupam is saying 3.75. Can you please check once again? So because both of these answers are like very different. Anyone who can cross verify, or maybe Anupam and Zoeb, you can check. So Zoeb is saying yes about what? Okay, so he's saying like he is correct. Okay, that's cool. Okay, so now let's suppose we are able to calculate our t value from a data is equals to 3.75. What is going to be a critical t? So can I say that critical t is going to be same 2.776? Yeah, critical t is going to be 2.776. It is not going to change because critical t has been calculated based on alpha and degree of freedom, df. So alpha has not changed, 0.05, degree of freedom has not changed. So if you will go to your table once again, you will be able to see the same value, 2.776. This value only you will be able to get in a case of two-tail test. Let's suppose we are trying to do. Fine. Okay. So critical T is going to be this much. So it simply means that this is my 3 standard deviation on negative side. This is my 3 standard deviation on a positive side. What is my allowed range? So my allowed range is technically this one, which is nothing but 2.776 on negative side, and my allowed range on this side is basically 2 point again 776 on my right hand side. What is a value that we are able to get? 3.75. So basically this is my critical range. Can I say that the red marks, this is my critical range on both hand side? So if anything is falling under this range, it simply means that I'm going to reject a null hypothesis. Can I make a statement here? Yes, everyone, or no? Yes, I think this is what we were trying to understand. Now tell me, we will reject or we will accept? I think we all have the answer. We are going to reject it, we are going to accept it. Everyone is saying reject, reject, and reject. Reason is very simple, right? So this is my, let's suppose, like a mu is equal to 0 origin, and 3.75, 3.75. So 3.75 will be above or beyond, I would say, my critical range, right? So it is actually falling under my critical area. Critical area means my null hypothesis is rejected. So are we able to make a decision? So I have just changed the data. And again, so if you will look into the data, this is what even data says, right? As this is the very small data we are talking about, but yeah. So in a very huge amount of data, maybe you will not be able to make conclusion. This is where you have to do the math. This is where you have to do the calculation. You have to go after the calculation. That's the reason. So we have like done the calculation. But this is a small data. Just by observation, I can simply say that. So with respect to this data, if teacher is trying to make a claim, it simply means that teacher is wrong. With respect to this data, if teacher is trying to make a claim, approximately there is a very high chance that teacher is going to be right. So are we able to understand T statistics, by the way, guys? Yeah. Are we able to understand T statistics? Fine. Now we are going to repeat our same process with respect to Z statistics also. I'll take a different case. So where we'll be having idea about a population, because we are going to do a Z test when we have an idea about a population. And there is something called as Z table, which is also available over the internet. And even to calculate a Z, so basically there are so many people who have created a website, or you can even calculate in a manual manner similar to this one. Steps are going to be same. Yeah. And then based on that, you can accept the null hypothesis or you can try to reject a null hypothesis. And exact same thing. You all will be using it in your machine learning chapters, almost all. Yeah. So everywhere you will be using it. So this is how this story starts, by the way. This is what we try to prove. We try to like disapprove things. Okay, so now we are able to understand a full hypothesis testing with respect to a t-test. We are even able to understand a p-value. We are even able to understand what is the meaning of hypothesis testing, right? We are even able to understand what is the meaning of a significance label, the risk that we try to consider. We are even able to understand which test we are supposed to take in what kind of a situation. We are even able to understand what is the meaning of a null hypothesis and what is the meaning of a alternate hypothesis. So all of these understanding now we all have. So I'll not discuss much. I think I have discussed enough. So take rest, try to digest all of these things what I have discussed in my today's class, right? Tomorrow we'll continue from the same step. We have to do a lot of math, a lot of calculations, so bring your calculator, or you can use a calculator which is available in your system. And yeah, so we'll do these things a lot, right? And I'm going to give you a lot of assignments as well. Plus, even inside your dashboard, now you will be able to find out the assignment option. We have built and we have released an amazing feature this week. I believe you are aware about it. So you will be able to get a beautiful, beautiful summary, uh, which is going to help you out in terms of doing a revision. I hope all of you have looked into that. It's an amazing feature that we have built. So whatever I have discussed last time, like mean, median, mode, right? Population versus sample, variance, standard deviation, normal distribution, standard normal distribution, skewness into a data. All of the summaries is available, right? Plus you can download even a raw data. Plus you can try to even chat with your video. Very simple, right? So a lot of AI we are doing, a lot of AI we have done in we have integrated. In the future, you will be able to see a lot of AI again, as we are AI driven company. I love AI. I love building things. So I just keep on building it. And here, so you have a quiz. So we have started giving you a quiz as well. And in every class, every live class, you will be able to find out a quiz, as well as you will be able to see your assignment over here, right? You will be able to see your assignments over here. So just go through these assignments, try to solve it, and then see. So if you're facing any kind of issues, right? So very, very deep topic today. Praveen is saying thank you. So sir, please attach this notebook to the last week attachment. Want to revise this topic. Which one? This one you were saying? This one? Let me import this, export to a PDF, and stats. What is the date today? 6th, right? So 6th December 2025. Okay, so let me save it. I will upload this one in your dashboard when we are going to upload the recordings. Yeah, so file is created. Okay, so now fine. This I'll upload. Don't worry. Fine. So along with that, so you will be able to see, summary and everything. That is a job which will be done by AI. Like I said, we are doing a lot of AI. We are not just teaching it. Okay. Sir, please. Okay, fine. Done, done, done. Okay. So if there is no question for me, so maybe in that situation, I'll rest my class. And last week notebook also, if possible. I think that is gone. You can take a snapshot. You can just like pause a video and then take a screenshot. Yeah. Because I was not able to save it, and I used to take a lot of classes, right? And even in my weekdays, so I do a lot of discussions, architecture, all the design for a lot of projects. So you can say it's gone. So can't upload it, but yeah, you can take a picture, and maybe you can circulate with everyone in a group. Suppose you are using OpenAI backend for creating a summary. This is too much bill you get. Yeah, I'm not afraid about a bill. Anyhow, we are not giving courses for profit, I believe, because entire year 4,000, 5,000, almost 12 to 18 live classes plus this one plus API access, so many things, right? So we can just do the math. I mean, like, no one is affordable, I believe, in this entire world. Not even Udemy, I would say. I can make this claim now. Uh, than us. Hope all of you will agree. Because we are not just giving recorded. Every month we are launching live classes, right? Two classes for this month. Next month is already planned. Again, next month, so my architecture class is going to come. Uh, so every month there will be live classes. Plus today itself we have published Tableau. We have published Databricks Big Data in Hindi as well as in English. Any mobile application development class? Not yet. We'll see in the future. But yeah, not yet. We have not planned for that. Yeah, maybe you can come under work and learn. We are building a lot of like a mobile application over there. So work and learn is a new feature that we have released. So if someone would like to go ahead with the work and learn, they can come and they can try to, join our team and they can try to work. So hope all of you are aware about this work and learn feature that we have. So maybe if you are not, then go and explore. This is an amazing feature. And I believe this is going to be a new big thing in our upskilling, because courses wise, like there are tons of courses available on YouTube, Udemy, everywhere, all the like a given platform. And again, like Now, yeah, 2 year, 3 year back, so it's completely fine. We can take time, we can learn, we can spend 6 months of time. But yeah, so now we can try to spend same 6 month of time, or maybe even 3 month of time, in terms of building a real thing, not just a demo, dummy one, because now dummy one can be built by AI, and that too in a half an hour, maybe 1 hour, right? So we can work on the real project, real client, even if you are experienced, or even if you are fresher, or even if you are dropout. And this is where this work and learn comes into picture. And I have a big plan for this. I have a big plan for this in terms of extending this work and learn in a future with other domain, robotics and all those things, right? Which we'll do. Maybe we'll work on that in 2026. That's a target for 2026 that I have taken personally. But yeah, so I believe this is going to be a new mode of upskilling, because we are not preparing for ITJ NEET. Yeah, in that case, obviously we have to prepare for the exams, maybe government exam, maybe UPSC, maybe NEET or JE. So over there, it's justified that we are taking our notes, we are spending 1 year of time, 2 year of time, and then we are going for the exam. But in upskilling now, courses are not that relevant, right? Courses are good to get some idea, to get some sort of a basic concept, right? Or to understand a basic system programming and all those things. Courses is going to play a role only till that particular part. The thing that you have to do is a building, because that is something that you will be able to, like, express in your interview. uh, So Sunil is saying that we are going to know how you have built this summary. So basically, we are trying to, like, fetch the transcript of all the recording. Even transcript you will be able. That's the reason. So we have provided you raw data. So if you'll go in any videos, right? So let's suppose if you are going into your class video, you will be able to find out the raw transcript. This raw transcript is actually coming from your this one, the video itself, and here you will be able to find out even a timestamp, right? So this is a main part. So we are trying to, like, process the entire video out of, whether it's a 2 hour video or 4 hour video or maybe a 10 minute of videos, and out of that, so we are trying to extract a transcript out of that. So then we are trying to generate a summary over here. Out of that, we are giving you this talk to video kind of a option. So obviously it's a heavy processing which happens in a backend in terms of, like, processing this video. Work will learn 100% remote. Any specific start date? No, there is no specific start date, because we have so many ongoing projects and we keep on taking a client project because of Euron consultancy and because of the SaaS that we are building, right? We are launching a SaaS in a month of January, and not on Euron. So Euron is a separate platform. My SaaS is a separate one. So yeah, I mean, like, so many projects which is already ongoing one again under consultancy. So there are so many white label product, white label client that we have, so many B2C client we have, and for them we are building, developing a product. So yeah, and again, so many internal development we have. Like, new concept come, how to deal it. I mean, like, see, if you have to keep yourself relevant, you have to keep building things. As simple as that. So as much you will participate, that is the only way. There is no other way, right? There is no other way. I complete the lecture and do practical, but after some time, that's normal, Aditya. That's normal for everyone. That's the reason. So I say some to everyone from the day zero of your class that if you are trying to do a upskilling, the best way of doing upskilling is by building things. It's completely fine. You have attended a couple of class, you are able to understand the basic of programming, stats, and all those things, but eventually you have to build things. And when I talk about this new era of AI, so in the new era, you can't simply pick some data from some repository and then just build some sample application, because that can be done by AI easily. So you have to solve a end-to-end problem, a real one, a client problem, a product problem, right? You have to solve. So if you're able to do it, then you will be relevant into a market. And obviously, you will not be able to forget things. Yeah. Can you give a brief out SaaS platform? Wait till January. You will be able to see, you will be able to experience it. Just wait for that. Apart from that, I'm creating one experience center. I mean, like, there are so many things which is going on a tech side. One by one, we'll release it. Yeah. So I learn the concept, but I do not make a project. Then I think you should not learn. If you're not building something, if you're not, like, solving the real problem, then there is no use of learning. I mean, like learning wise, we all have done a learning for 20 year, 22 year, 25 year, right? A school, then college, and then like, someone is going for a master, someone is going to a PhD. So I'm like, what is the use of that learning if you can't build something? Because industry is not going to nowadays, the trend which is going inside the industries from day zero, day one, they are going to onboard you. They are going to expect an outcome. They're not going to give you a time that, okay, take 3 months of time and then, go through a training and do this, do that. No, that is not going to happen in a current environment. And again, this environment is evolving a lot. In last 3 years, it has evolved a lot. And in 2025 itself, it has evolved a lot. In 2026, you can expect even more. So yeah, you have to like, you know, go with the same speed. Sir, Euron will help us to build something if I want. Yeah, that option is available under consultancy. So student option is available, professional option is available, plus startup option is available. So you can go, you can opt for that. In case of any confusion, talk to our team. They will guide you that which option you should choose. And yeah, so because we are developing for students as well, so we are doing a lot of student project. We are writing a lot of research paper because some PhD students, some like master students are coming to us saying that from India and outside India also that okay, this is a paper, like this is the project that I have opted for, this is the research paper, so can you please help us out? So under student plan or professional are coming, they are saying that I'm building my startup. So that's the reason in Iran consultancy comes into picture. My friend do a project with the AI to Z and he do not know about the project, but it make it, I mean, like if he's just doing a vibe coding, I don't know what kind of project he's making, but yeah, I can't comment on that. Okay, fine, guys. So, can we discuss choose what project will be involved working before joining? No, we are going to assign you a project from a beginning. You can choose a technology. For example, you're saying BEV, you're saying AI, you're saying mobile. You can choose a technology project. We will assign you. It's going to be a good one, obviously, right? And then in a later stage, after working for a couple of weeks, you can change the project. Maybe join a different team who is working in a different project, right? That option will be available. But yeah, initially we are going to assign you the project, and then in a couple of weeks, you can go and change it. That flexibility you have. So fine, guys. With that, thank you so much. Take care. Is it remote? Everything is remote. Yeah. There is a part of part time or weekend also. Yeah, that is available as a part time and weekend also in both the mode. For that, so we have a project manager who is going to do all this sync up and management. Unless to want to switch into a product base, then start building something, Sunil. Yeah. Okay, fine, guys. I think we have done enough discussion. See you tomorrow with the same, like extension of the same topic. So I'm going to talk about a hypothesis with respect to a JED test and with respect to a chi-square, with respect to a ANOVA. So all of these concepts I'm going to cover again in an interesting manner. So step by step, we'll try to understand each and everything. So with that, thank you so much, everyone. Take care. See you again tomorrow.